So let's just go ahead and start applying Charles' law. So we're going to start with this first problem, a helium-filled balloon. Remember, whenever we hear balloons, we're pretty sure we're dealing with Charles' law. So a helium-filled balloon has a volume of 275 liters at 20 degrees Celsius. So I'm going to start by identifying what variable 2.75 liters is. So that is my volume 1, 2.75 liters. That's my volume 1 at 20 degrees Celsius. That's my temperature 1, 20 degrees Celsius. And remember, as soon as we see that we're in Celsius, we need to change that to Kelvin. We cannot keep things in Celsius for Charles' law. So we immediately add 273. So temperature 1 is 293 Kelvin. Okay, that's immediately what we do. We don't leave it there because we'll forget. Okay, then it says the volume of the balloon decreases to 2.46 liters. Liters is a unit of volume. So I already have one volume. This must be my second volume. So I have V2 equals 2.46 liters after it's placed outside on a cold day. What is the outside temperature? T2 is what we're trying to find. Now, what you'll notice is it didn't say that the pressure was constant. What it did say was balloon, okay? Balloon means constant pressure because balloons expand. They're not a rigid container. They don't put pressure back when you try to expand in them. So because the balloon itself expands, we know that pressure is constant. So remember, this is my given and my find of the problem. Okay, that's my given and my find. So for my use, I'm going to need to choose a equation that has both volume and temperature in it. So of course we're going to use Charles' law, which is V1 over T1 equals V2 over T2. These laws will be provided on the test. You'll just need to know which one you need to use, okay? So that's given, find, use. Now we just plug into this. Plug in. So V1, 2.75 liters over T1. Remember to use our number in Kelvin, 293 Kelvin equals V2, 2.46 liters over T2. That's what we're trying to solve for, is T2. And so what we're going to need to do now is we're going to need to plug this in to our calculators. So get your calculators out. There are two ways to solve this, but the one I find most useful for students is a cross multiply. So what we're going to do is we're going to multiply these two and then divide by that. Okay, cross multiply tells us to multiply our diagonals and then divide what's left over. So I'm going to say 293 times 2.46, and then I'm going to divide that by 2.75 to give me 262.10 Kelvin. So T2 equals 262.10 Kelvin. Remember, if you're typing this out, that you're going to put a space here and Kelvin's going to be capitalized. So this would be my answer for my outside temperature. Now, one good thing to ask yourself is, does it make sense? Okay, when the volume decreases, the temperature should also be decreasing. So I want to make sure that my answer is less than the temperature I started with, and it is, so I can leave it just like this, and I know that I've solved it correctly. Okay. All right, we're going to start the next one. We're going to read it together and get you guys started, and then I'm going to want you guys to solve the last problem. Okay, so make sure you have this written down before we go on. All right, so for the next problem, we're going to have a gas at 65 degrees Celsius. What is that? 65 degrees Celsius is a temperature 1, 65 degrees Celsius. I don't even want to leave it there, even to finish the problem. I want to immediately take my 65 plus 273 to get it into Kelvin. This is 338 Kelvin. Remember, we do that by adding 273 to get there. Okay, so I'm going to immediately change my T1. Occupies 4.22 liters. 4.22 liters is a volume. What Celsius temperature? That tells me temperature 2 is what we're trying to find, but it does something very special here. It tells us it needs to be in Celsius, which means that at the end of my problem, I'm going to need to subtract my 273 to get my Celsius temperature because I need to go back into Celsius. My initial solution is going to be in Kelvin, but then I need to go back into Celsius for the proper answer, okay, for the full credit answer. What will the temperature be, or what Celsius temperature will the volume be? 3.87 liters. Volume 2, 3.87 liters, 0.87 liters, and it tells us pressure is constant. Okay, so this is my given and my find. Okay, so I want you to go ahead and solve this and then put it in the answer. And then I'm going to continue on and finish solving the problem when you're done. Okay, so go ahead and solve it. Okay, all right, so now what you should have is you should have plugged in. Oops, we need to pick our U's. Okay, our U's is easy right now because we're doing problems with this like great Charles Law title on it, so we know which one to use. V1 over T1 equals V2 over T2. And so then I go ahead and I plug in. And so I'm going to say V1, 4.22 liters over T1, 338 Kelvin equals, and then I have 3.87 liters over T2. I plug this into my calculator. Again, cross multiplying, multiply here, and then divide, multiply first, and then divide. So I do 338 times 3.87 divided by 4.22. And first, remember, I'm expecting a number lower, right? Because my volume goes down, so my temperature should be going down. I get T2 of 309.97 Kelvin. But is that my answer? No, it's not my answer because it told me that it wants Celsius. So I have to take this answer and subtract minus 273. So minus 273 gets me an official answer of T2 equals 36.97 degrees Celsius. Final answer. That's the one that you would enter on the quiz or the test to get full credit for. So I hope that helps. And if you guys have any questions, make sure you write them down so that you can ask me tomorrow in class and we can go over them together. All right, have a great day. Bye, guys.